Hello everyone, welcome back to our 100 days of ML machine learning tutorial. Today we are diving deep into linear regression, which is a powerful machine learning algorithm. It's a foundational concept in machine learning as well. It's often the first algorithm you will learn, and that's for a good reason. So we'll explore this simple yet very powerful linear regression machine learning algorithm tool, which helps us make predictions more accurate. So think of linear regression as the simplest machine learning in our AI factory. It takes numerical inputs, gives us a continuous predictions like housing prices. So this isn't about classifying things. It's about predicting a specific value. We are looking for a direct linear relationship between what we know and what we want to predict. Now, at the heart of this linear regression is the simplest question. This equation is y equals to mx plus b. This isn't just a math, it's a core engine of our prediction. So y is what we are trying to predict, like a house price, as I tell you. X is our input, such as square footage. M tells us how much y changes with x, and b shifts our prediction up or down, which we call bias as well. So how do we find this right M and B? So finding this line, the best fit is our objective of linear regression. So we want a single straight line that best represents the trend in our data. This line minimizes the residuals, which are the distance between the actual data points and the predicted line. It's all about finding that sweet spot where our line is as close as possible to all the data. Next, we'll see how we measure if our line is actually any good or not. So how do we actually measure if our line is of best fit? So that's where this MSE, we call it mean squared error, comes in. It's our go-to quality control metric for all the regression models. We square the difference between what we predicted and what actually happened. It makes sure all the errors are positive, and it really pushes those big mistakes for smaller ones. So now our whole goal is to find the right M and B values that gives us the absolute lowest MSE, which is the mean square error. This tells us we have found the best possible fit for our data. And now we'll actually go finding the perfect M and B values as well. We call it optimization technique, which is the most popular optimization technique. We call it gradient descent. So finding that minimum MSE isn't something we can just guess. We need a smarter way to get there as well. And that's where like GDs, we call it gradient descent optimization technique. So think of it like you are blindfolded and you are on a hill trying to find this lowest point on the hill, and you will feel around and go step by step and take the steepest downward slope and take small step in that direction. Now you keep repeating this same procedure until you find the lowest point. So gradient descent does exactly that, but it does it mathematically. It calculates the steepest path down the error curve, now taking a small iterative steps, and this process keeps going, refining our M and B values until we hit the sweet spot between this lowest MSE, which is the exact value of lowest MSE, and it's how our model learns to tune itself as well. So these are the three things which are very important to building these predictive models. So today we are really build a foundation model for understanding how AI makes predictions. Linear regression isn't just like simple line, it's a like powerful concept that underpins so much of what we do in machine learning. We saw how the equation transforms our data, which is y is equal to mx plus b, and how MSE acts as a quality check, and how gradient descent is the engine that fine tunes everything. So our ultimate goal is always to find that optimal prediction path, that line which fits the best. And with this, we have completed our day 4 of 100 days of ML, and we'll be building a solid understanding of the core AI principles and the concept. in the future videos as well. Thank you so much, everyone.